Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is a pure mathematics 1 for October-November 2023, and the code is 9709/11. So let's move on to question number 1. Question number 1a. Expand 1 plus 3x to the power of 6 in ascending powers of x up to and including the term in x squared. Okay, so just copy the question first. Alright, our formula is a plus b to the power of n equals to an plus plus nc1 an minus 1 b degree 1 plus nc2 an minus 2 b squared plus until b degree n. Okay, so for this case, it will be 1 to any degree will be 1. Then here 6c1, 1 to degree 5, 3x degree 1, plus 6c2, 1 to degree 4, then 3x degree 2. Okay, so from here, you will be getting 1 plus 18x plus 135x squared. So these are the three terms in this expansion. Now B, hence means use the previous answer. Find the coefficient of x squared in this expansion. So I'll rewrite the question first. So we have done the degree 6 of 1 plus 3x just now. So the first term with degree 1, no need to do any expansion. So just rewrite. And then for the second expansion, it will be replaced by these three terms. So I will get 1 plus 18x plus 135x squared. Okay, now when you look at the question, we are just interested to find the coefficient for x squared. Means that now I will ignore the rest of the terms. I will just concentrate for the terms with has x squared. Alright, I mean after you expand, you get x squared. So then from here, the 1 must multiply with 135 x squared. Then the minus 7x multiply with 18x. Then the x squared just multiply with 1. Okay, and then from here, when you get the total of all these terms, it will be 10x squared. Therefore, the coefficient of x squared is 10. So that's the solution for B. Okay, now for question number 2. A line has equation y equals to 2cx plus 3 and a curve has equation y equals to cx squared plus 3x minus c, where c is a constant. Showing all necessary working, determine which of the following statements is correct. Now A, the line and curve intersects only for a particular set of values of c. B, the line and curve intersects for all values of c. And then part C, the option C is the line C and curve do not intersect for any values of C. Okay, so now we need to find whether there is any intersection or not. So no matter how, we just assume they are intersecting first and see any solution when we consider the intersecting lines. So I'll let this be first equation and then the quadratic be the second equation. So to solve this, I will just equate them. Alright, so I will be getting 2cx plus 3 equals to cx squared plus 3x minus c. And rearrange this to get the quadratic equations. Since the cx squared is on the right side, so all the terms will be moved to right side. Okay, then from here, I will be getting cx squared plus 3x minus 2cx, then minus c minus 3 equals to 0. Then from here, I will simplify them. So for the second and third term, you factorize the x to get 3 minus 2c. And then for the fourth and last term, you factor as a negative. Then I will get negative of c plus 3 equals to 0. Then now the discriminant is basically b squared minus 4ac. But since there is a c here, or probably I will just write my a is c, my b is 3 minus 2c, then my capital C is negative of c plus 3. Okay, so discriminant equals to b squared minus 4ac. So now replace the terms. So 3 minus 2c squared minus 4a is c. Then the c, capital C, is negative of c plus 3. Then from here, I will do expansion. Now for the first one, quadratic expansion, a plus b squared equals to a squared plus 2ab plus b squared. So 3 minus 2c, you square it, it will be 9 minus 12c plus 4c squared. Then for the next one, the minus and minus becomes plus. This is 4c. So 4c multiplied with c, it will be plus 4c squared. Okay, then 4c multiplied by 3, it will be 12c. Then now from here, I have to simplify. So now negative 12c and 12c will be cancelled off. That means the total of 4c squared and the 4c squared will be 8c squared. Then together with plus 9. Now when you look at the question carefully, c is a constant. So it means that any numbers. So from here, right, c squared, it will be always 0. Okay, I mean not to say always 0, always greater than or equals to 0 for all c values. Okay, for c is real number. So since this is at least 0, then at least 0 will plus with 9. That means your discriminant is actually at least 9. Okay, so when discriminant is positive, this is positive. Therefore, you will get 2 roots. Okay, it can be 2 real roots. I would say 2 real and distinct roots. Now, we get these 2 real and distinct roots when we solve the simultaneous equations. Means we are finding the intersection points. So basically, they will be intersecting at 2 different points, okay, for any c value. Alright, so which means the solution is B. So the statement B is correct. So A is wrong because it's just intersect for particular C, but actually it's not because it can be for real number of C. Okay, therefore statement B is correct. Alright, so that's the solution of this question. Now, next question number 3. The diagram shows a cubical closed container made with a thin elastic material which is filled with water and frozen. During the freezing process, the length x centimeter of each edge of the container increases at a constant rate of 0.01 centimeter per minute. The volume of the container at the time t minutes is V cm cubed. Now find the rate of increase of V when the x is 20. So first of all, I will have to write down this 0.01 is the rate of the x increases. That means dx dt is positive 0.01. Okay, and then the volume is V centimeter cube. So since this is a cube, alright, it's a cuboid, I mean cubical closed container, so the volume is base area times height. That means it's x cubed. So from here, I will get V is x cubed. And now you need to find what is the rate of the increase of V. So you need to find what is your dV over dt. Okay, so from V equals to x cubed, I will get dV over dx. That is 3x squared. So then you need to find when x equals to 20. So when x equals to 20. That means now, okay, I will write dV over dt. By using the chain rule, it will be dV over dx. times dx over dt. So my dv over dx is 3x squared. Now at the same time my x is 20, so it will be 3 times 20 squared times dx dt is given 0.01. Therefore, you will be getting 12 centimeter cube per minute. So this is the solution for question 3. So for question number 4, the transformation R denotes the reflection in the x-axis and transformation T means the translation. A. Find the equation y equals to fx of the curve with equation y equals to x squared. Okay, this is the original curve after it has been transformed by the sequence of transformations R followed by T. Okay, so when y equals to x squared, after the transformation of R, because the R means reflection in the x-axis, which means it's like this. Okay, this is the x-axis, this is y. So after the reflection in the x-axis, this is your graph. That means all the positive becomes negative. So I will be getting y equals to negative x squared. Okay, and then after the transformation of t followed by the transformation of t, t means translation 3 minus 1. This 3 means that you move the graph to the right side for 3 units. So it will affect the x coordinate. Okay, and then you move down the graph for the y for 1 unit. That means this will be affecting the y coordinate. Then this is affecting the x coordinate. Okay, so then since you move the graph to the right side for 3 units, that means your y becomes negative. Instead of the x, now becomes x minus 3. Then square it. Okay, and then you move down the graph for 1 unit, so minus 1. Therefore, your gx, because your y equals to gx is the new curve, it will be negative times negative of x minus 3 squared minus 1. So this is the solution for A. Now B, find the y equals to hx after the first same graph y equals to x squared, okay, of the same graph after the transformation t and then r. So t first. When t first means that translation first. So which means the x will be changed to x minus 3, then the graph will be moved down. So I will change to the x will be changed to x minus 3 squared and then move down. So minus 1. Okay, then followed by the r. Remember, the r is a reflection. Means that now you just need to times a negative to the original graph. So which means after the r, your y is negative of the existing function. So that means here I will just write negative of x minus 3 squared plus 1. So my hx, it will be negative x minus 3 squared plus 1. Okay, so done for the parts B. And then C, state fully the transformation that maps y equals to gx to y equals to hx. So when gx to hx, that means gx is negative of x minus 3 squared minus 1 to negative of x minus 3 squared plus 1. Okay, so now from here, I will say the second function, the hx, is basically negative x minus 3 squared minus 1, which is our gx here, then I plus 2. So that means this is gx plus 2. Okay, so when gx plus 2 means that you are actually moving up the gx 2 units, which is a translation. So this is transformation. It will be a translation of 0, 2. Okay, so that's the part C. For question number 5, show that the equation may be expressed in this form, which is a quadratic equation in terms of cos x, where a, b, c are integers to be found. So first of all, I copy down the question. 4 sine x plus 5 over tangent x plus 2 over sine x equals to 0. So now, the over tangent x, we know that tangent x is sine x over cos x. So when 1 over tangent x means 1 over sine x over cos x, which is cos x over sine x. Okay, so I will change to this form first. Okay, since now denominator has sine x, I will times the whole equation by sine x. Then I will get 4 sine square x plus 5 cos x plus 2 equals to 0. But then when we look at the question, we need cos square x instead of sine square x. So then we have to apply another identity, which is which is sine square x plus cos square x equals to 1. Which means now sine square x is 1 minus cos square x. Okay, so I will get 4 bracket 1 minus cos square x plus 5 cos x plus 2 equals to 0. Then now you do expansion, it will be 4 minus 4 cos square x plus 5 cos x plus 2 equals to 0. Then you can just write, okay, move all the terms to right side. It will be 4 cos square x, then minus 5 cos x. This 4 plus 2 is 6. When you move to the right side, it will be minus 6 equals to 0. Okay, so done for this. So it means that your A is 4, your B is minus 5, and then your C is minus 6. Now part B, hence solve the equation. So exactly the same equation, therefore I will just copy. Okay, so 4 cos square x plus 5 cos x minus 6 equals to 0. Now your x from 0 to 360 degrees. Then from here, when you factorize this quadratic equation, you will be getting cos x minus 2 times 4 cos x plus 3 equals to 0. So then multiplication of two factors equals to 0 means one of them must be 0. Either the first one is 0 or the second factor is 0. So when the first factor is 0, cos x is 2. So we know that this one has no solution because for the cos x maximum is 1, minimum is minus 1. So it will not be reaching 2. Then 4 cos x plus 3 equals to 0 means that your cos x equals to 4 cos x equals to negative 3. So cos x is negative 3 over 4. Okay, by looking at this domain, the interval of x, when the cos x is negative, that means by referring to the quadrant, the angle should be in second and third quadrant. So now, when you press your calculator, inverse cos 3 over 4 without the minus, you will get the acute angle, which is 41.4 degrees. Okay, so by looking at this quadrant diagram, I will get 180 degrees. So my first angle is basically this orange color, and then my second angle is the major angle. So which means I will get 180 degrees minus 41.4, and another one is 180 degrees plus 41.4 degrees. Therefore, you will be getting 138.6 degrees and 221.4 degrees. So that's the solution of the x. Okay, now for question number 6. The diagram shows a motif formed by a major arc AB of a circle with radius R and center O. And the minor arc AOB, so here is the AOB, okay, of a circle with radius R but with center C. Right. Okay, the point C lies on the circle with center O. So here, the point C, this is the center. Right. Given that angle ACB is K pi, so ACB here is K pi. State the value of the fraction K. Okay, so now we know that central angle, okay, here, central angle, which is here, because the O is the center. Okay, so this central angle is double or is twice the angle, twice any subscribed angle subtended by the same arc. Alright, that means this AOB, the angle AOB, the upper one, is double of angle ACB. Alright, so from here, because we know that AO is same as AC, both are R. Okay, so now I will say AO, or I will say, okay, you want to find the K, right? You want to find the K. I will say major angle AOB, which means it's here. This is a major angle AOB, is 2K pi. Because I say this angle is double, is twice K pi. Okay, and then now you need to find the K. Okay, what is the K value? Then we know that the total angle here, total here is 360 or 2 pi. Alright, since here is 2K pi, then I will add up. Okay, this is going to be, right, this is going to be how much? So we need to find, because here is R, this is also R, it's like you flip it. That means this angle is actually K pi. Alright, here is actually K pi as well, because when you flip, right, this angle is same as this angle. Therefore, from here, I will write AO equals to AC. That means angle AOB, which is here AOB, the other part, equals to angle ACB. Okay, so this is a minor, that it will be K pi. So from here, I know that upper part is 2K pi, the bottom part is K pi. So 2K pi plus K pi equals to 2 pi, because that is the whole circle. Therefore, 3K pi is 2 pi, hence my K is 2 over 3. Okay, so this is the K value. Now B, state the perimeter of the shaded motif in terms of pi and R. Okay, state. So now, from here, from this diagram, we know that this part, okay, this is the arc length of this vector. I mean, this sector. Okay, this sector. So, arc length formula, let's say you are given a sector. This is R, this is theta. The angle is theta. So, the arc length is theta R. So, now we know that this is R, radius is R, the angle is 2K pi. So, I can find this easily. Okay, and then to find the other one, which is here, this part. Remember, this part is the arc length of the sector ACB. Okay, ACBO. That means the angle is K pi. And then again, the radius is R. So now basically my perimeter is the first one, the angle is 2K pi. And then the radius is R. And the second one, which is a green color, the angle is K pi. So K pi times R. Right? So from here, when you get the total, it will be 3K pi R. And then now you need to get theta and pi and R, replace the K. So the K we already found. Okay, or probably you can just direct refer to this. 3K pi is 2 pi. So I will just replace this 3K pi by 2 pi. Then that will be faster. Okay, replace this by 2 pi. So here I will just write 2 pi R. Okay. Now see, find the area of the shaded motif, giving your answer in terms of pi, R, and square root 3. Okay, so for this case, to find the shaded region, basically shaded region, what I need to do is, I need to find the area of the sector first, area of this sector. Okay, now let me erase all this first. So when you look at the sector here, when I find the sector, area of the sector means I'm finding this. Okay, so I'm finding 1, 2, 3. So then I have to minus the 2 and 3, the part 2 and part 3. So the part 2 and part 3 belongs to the sector of AOB. Okay, so it means that now I have to minus the sector AOB later on, and then I plus back this sector number 4. Alright, so now I have to find one by one. So for the sector number 1, which is a major sector of AOB, so here, area of major sector AOB. Now, let's say this is a sector. Here is R, this is theta. The area is half R squared theta. Okay, so major sector of AOB means that it will be this angle we have found 2K pi. Right, so then 2K pi, okay, I will just write half R squared, remain R squared, 2K pi, whereby the K is 2 over 3. Okay, we have found in the first part. So now I will get the half and 2 will be cancelled off. Then I will just get K pi R squared. So my K is 2 over 3. So I will get 2 over 3 pi R squared. Okay, now I have to find the triangle. Okay, so from here, since we know that this is K pi, and here is R, right? So I can find an area of AOA. That means it's here. So AOA is basically how? Area of sector minus area of triangle. Okay, then divide by 2. So what I need to do here is, I will say area AOA okay, so AOA, that means I will just draw like this. I cut into 2. So I will consider this whole sector, okay, minus this triangle. That will be the area number 2. So if I draw the diagram, here's R, this is A, right? This is, now, what is the angle over here? Since this initial angle was 2 k pi, okay, here is k pi. So now I cut it into 2 parts. That means this part is half k pi. Okay, here is another half k pi. Alright, so from here, I will label this as half k pi. So now, I will say this is same as area of sector minus area of triangle. So area of sector formula, half r squared theta. So half r squared, the theta is half k pi, minus area of triangle. So we have a formula here. If let's say this is A, here is B, this is theta, it will be half AB sine theta. So since this angle is given, so I can just write half r times r, that means these two sides, then sine half k pi. Okay, and again, now remember your k is 2 over 3. Therefore, this is going to be 1 over 4. Half is 1 over 4. Then the k is 2 over 3. Then pi r squared minus half r squared sine half times 2 over 3 pi. Then here is going to be, okay, 1 over 2. Sorry, this is going to be right. So here you will get 1 over 6 pi r squared minus, this one cancel, sine 1 over 3 pi. Sine 1 over 3 pi is sine 60 degrees. So root 3 over 2. So half r squared root 3 over 2. Okay, so from here, basically, if I don't want to expand this, okay, from here probably I will just take out. That will be easier. I will, because I have half on the right side, on the second term, so I will remain this as half. Then here is 1 over 3 pi r squared. It will be better, easier. Okay, then from here I will factorize half r squared. Once I factorize half r squared, then I get 1 over 3 pi minus root 3 over 2. Okay, this is just area of AOA, alright? So means that just now we have found the first part, and now we have found this part. So what we do here is I find the first part, I mean the whole sector. Whole sector is basically 1, 2, and 3. So I just need to minus 2 and 3. So 2 and 3 are the same. Therefore, now my area of the shaded region will be area of the major sector minus double of area AOA. Okay, then from here you can simplify. So the half and 2 can be cancelled off, and then this minus I bring in. Alright, so it will be 2 over 3 pi r squared. So minus r squared, here is minus r squared, together with the pi over 3, you get minus pi over 3 r squared. Then the minus r squared multiplied with minus square root 3 over 2 is plus square root 3 over 2 r squared. So the first and second term can be simplified. 2 over 3 pi r squared minus 1 over 3 pi r squared. You will get pi over 3 r squared, then plus root 3 over 2 r squared. So from here, I will factorize 1 over 6 r squared. So then you will be getting 2 pi plus 3 square root 3. So this is the area of the shaded region. Okay, next question. The sum of the first two terms of geometric progression is 15, and the sum to infinity is 125 over 7. The common ratio of the progression is negative. Find the third term. Right, so from here, GP, first two terms, sum of first two terms, so T1 plus T2 is 15, given S infinity is 125 over 7. The common ratio is negative. So now for GP, geometric progression, Tn is AR to the power of n minus 1. The S infinity is A over 1 minus R. So A is the first term, R is a common ratio. That means the T1 here is A, then T2 is AR equals to 15. Then from here, by factorizing A, you will get A times 1 plus R equals to 15. Therefore, my A is 15 over 1 plus R. This is my first equation. So when S infinity is 125 over 7, just use the formula. It will be A over 1 minus R equals to 125 over 7. Then from here, I use cross multiplication. Right. So it means that 7A equals to 125 times 1 minus R. Okay. Then now the A will be replaced. So substitute first into second equation. So 7 times 15 over 1 plus R equals to 125 times 1 minus R. So now the 1 plus R will be moved up. Now the left hand side 7 times 15. Then right hand side 125 times 1 minus R times 1 plus R. So 7 times 15 it will be 105. Then 125, 1 minus R times 1 plus R, we have a formula. A minus B times A plus B, it will be A squared minus B squared. Okay, therefore from here, I will get 1 square minus R squared. Then you will be getting 125. Okay, so from here, I will get the R, right? So you can just do expansion. It will be equals to 125 minus 125 R squared. Then from here, by moving the negative 125 r squared to the left side and 105 to the right side, so I will get 125 r squared is 125 minus 105, which is 20. Therefore, my r squared is 20 over 125, which is same as 4 over 25. And then you will be getting the r as plus minus square root of 4 over 25, that it will be 2 over 5, plus minus. But then in the question is mentioned, r is less than 0. So when the r is less than 0, therefore the r must be negative 2 over 5. Okay, so with this we have to find the a. Now my a from the first equation. So from first equation, my a is 15 over 1 plus r, which means this is 15 over 1 plus negative 2 over 5. Therefore, this is going to be 25. Okay, and now when you look at the question here, you need to find third term, T3. So, T3 is AR squared. So, it means that it will be 25 times negative 2 over 5 square. So, at last, you will be getting 4. So, this is your final solution. Okay. Now, for question number 8. The diagram shows the curve with equations. These are the two equations meeting at points A and B. So these are the 2 points. A, by using the substitution u equals to 2x minus 3, find by calculation the coordinates of A and B. So means that the A and B are the intersection points between these two curves. So now, and at the same time, use the substitution. So y equals to 2 times 2x minus 3 degree 4. Okay, and then the y equals to 2x minus 3 squared plus 1. So when the u equals to 2x minus 3, that means my first y is 2. The 2x minus 3 is u, so u degree 4 as my first term, or as my first equation. Then for my second y, it will be u squared plus 1. Okay, so since they're intersecting, now we need to solve simultaneous equations. Let the first equation equals to second equation. So 2u degree 4 equals to u squared plus 1. That means 2u degree 4 minus u squared minus 1 equals to 0. Now, this can be factorized. So you can let u squared equals to a, or if you don't want, you just remain in this form. Okay, probably I just write let a equals to u squared. That means this is 2a squared minus a minus 1 equals to 0. Okay, then here I will get 2a plus 1. Then a minus 1 equals to 0. That means a is negative half or 1. Now change back, which means now your u squared is negative half or u squared is 1. So we know that u squared cannot be negative. That means there's no solution for the first u squared. Okay, so now u squared is 1. Therefore, your u is plus minus 1. Now, refer back to your u. Your u is 2x minus 3. So which means now 2x minus 3 equals to 1 or 2x minus 3 equals to minus 1. Okay, now let's look at the question. You need to find coordinates of A and B. So it means that you need to find 2x values. So which means 2x equals to, move the minus 3 to right side becomes 4. Then your x is 2. Or the other one is minus 1 plus 3 is 2. Then your x is 1. So after you have found these 2x, we need to find the y coordinate. So your y, you can just substitute into one of them. Alright, so I can just use back this. Okay, so y equals to 2u degree 4. So from first, y equals to 2u degree 4, we know that u squared is 1. Okay, so u degree 4 means square of u squared. So I will get 2 of 1 squared, which is 2. Right? Then when the other one, right, it will be the same. So now I know that for both y, it will be the same. Therefore, the point A, now let's look at the graph. Now you are getting x equals to 1 and 2. So obviously the x coordinate of A is 1, the B will be 2. Okay, so here it will be 1, 2, and then the B is going to be 2, 2. So that will be the solution of the question. Okay, now B, find the exact area of the shaded region. So for shaded region, right, let's look at the diagram. Now from here, obviously, this is the region under this graph. Okay, under the upper graph, minus area under the lower graph. Okay, so this is the lower graph, means that 2x minus 3 squared plus 1, this area minus the lower graph. Alright, so now, and then your limits will be from A to B. So I will write area equals to, the A is 1, B is 2. So 2x minus 3 squared plus 1 minus the lower graph. The lower graph is 2x minus 3 to the power 4. So for this case, right, when we need to do integration, I can refer to this formula. Integrate ax plus b to the power of n. It will be ax plus b to the power of n plus 1 over the new degree. Then when you differentiate ax plus b, it will be a plus c, provided the n is not minus 1. Okay, so now since it's, and provided the degree of x is 1, it must be a linear function. So since the function inside the brackets, the both brackets are linear, therefore I will just use this formula, which means this is 2x minus 3. Then the degree 2 becomes 3 over the new degree, and differentiate 2x minus 3, it will be a 2. Then integrate plus x, plus 1 is x. Then minus 2. 2x minus 3 remains. Degree 4 becomes 5 over 5, and differentiate 2x minus 3 is 2. Then consider limits. There's no plus c here because you have limits. Then from here, I will simplify it. 2x minus 3 cubed over 6 plus x minus, okay, the 2 will be cancelled off. Then you only get over 5. Okay, so now replace the x by 2. So when you replace the x by 2, this is 4. See here, 2 times 2 is 4. 4 minus 3 is 1. That means both are 1. Okay, so I will write 1 cube. 1 cube is still 1, so 1 over 6 plus 2 minus 1 over 1 degree 5 is 1, so 1 over 5. These are the values when x equals to 2. And minus, when the x is 1, so 2 times 1 is 2. 2 minus 3 is minus 1, so minus 1 cube, you still get minus 1. Okay, then minus 1 degree 5 is still minus 1. Then from here, the first bracket, it will be 59 over 30. Second bracket is 31 over 30. So at last, you will be getting 14 over 15. So that is the area. Okay, next question 9a. Express this quadratic in this form where a and b are constants. So to get the completed square form, we need to carry out the completing the square method. Okay, according to completing the square method, you must get coefficient for x squared be 1. So it means that we need to factorize the 4. So I will factorize 4 from first two terms. You will be getting x squared minus 3x. Then plus 13 at the back. Now, according to the completed the square method, rewrite the first two terms and then plus bracket squared minus bracket squared. Then copy last term. Now, the term inside the brackets will be half of the coefficient for x. Means that half times minus 2, you will be getting negative 3 over 2. Okay, then from here, I will get 4 bracket. Now combine the first and third term. So you will be getting x minus 3 over 2 squared. Now for the last term, which is here, you need to simplify. So I will be getting minus 9 over 4. Then plus 13. So this 4, bring it in. Okay, bring it in. Then here you will be getting 4 times x minus 3 over 2 squared. So 4 times negative 9 over 4 is basically minus 9. then plus 13. Now we look at the question here. Square of 2x plus 8. That means I need to bring in the 2, the 4. So this 4 I can change to 2 squared. Minus 9 plus 8 plus 13 is basically plus 4. So we have a formula over here. A squared b squared is same as ab squared. Okay, so now I can just write this is 2 times x minus 3 over 2, then everything squared, then plus 4. Okay, and then this 2 times in, so I will be getting 2x so negative 3 over 2 times 2 is negative 3. So this is my form. Okay, now the function f is defined by the same function. Okay, same function, but then the x is defined from p and q, from p to q, where p and q are constants. The function g is defined by straight line 3x plus 1, where the x is less than 8. Given that it is possible to form a composite function gf, find the least possible p and the greatest possible q. Okay, so from here, right, composite function gf. So when you refer to this diagram, here is gf. We start with f first, then followed by g. Okay, that means this is the range f, and at the same time it's also domain g in this group. So I have this idea. Range f and domain g will be the same. Okay, so from here, my fx is 2x minus 3 squared plus 4. Okay, then now x between p and q, and then my g is 3x plus 1, x less than 8. So that means from here, I know that domain g is x less than 8. Okay, since domain g equals to range f, for the gf function to be exist, therefore my range f, it will be same as domain g. So but then the x have to change to fx. It's less than 8. Okay, so my fx here, this is my fx. So you can write fx less than 8. So you can either use back this form or this form, up to you. Alright, so I will use back this form, easier, because this is already a quadratic. So I will just write 4x squared minus 12x plus 13 is less than 8 because of here, fx less than 8. Okay, so this one I just write back the quadratic equation, quadratic function. So now, to get the p and q, I just need to find the x values from this inequality. What to do is move the 8 to the left hand side and solve the quadratic inequality. Then here I will be getting 4x squared minus 12x. 13 minus 8 is plus 5. Then less than 0. Factorize this, you will be getting 2x minus 5 and then 2x minus 1. Okay, so basically here I get to 5 over 2 and half. So now this graph, okay, 4x squared minus 12x plus 5 will have a minimum points because of the positive 4x squared. So this is a graph, and then it will be touching the x-axis at 2 points, 5 over 2, which is 2.5, and then this is half. So I will label here half. This is 5 over 2. Now the whole graph is less than 0. Look at here. Right, less than 0 means the region is below the x-axis. So that means I will get my x between half and 5 over 2. So now if you compare with this, okay, so by comparing x between half and 5 over 2 with x between p and q, So obviously the p is half. Okay, so therefore the least p is half. The greatest q is 5/2. Okay, so this is the solution of this question. Now see, find the expression for gf. So gfx, it is g, my fx, okay, go back to the fx, it is a quadratic. Alright, just copy this. So 4x squared minus 12x plus 13. Just now our gx 3x plus 1. Okay, so here you have to replace this x by these three terms. So it means that now I will be getting 3 times the three terms and then I plus 1. So then when you do expansion, it will be 12x squared minus 36x plus 40. So that is our gfx. Now the h is defined by this same function, but then x is less than 0. Find the h inverse. Okay, so now let y equals to hx. That means the y is 4x squared minus 12x plus 13. So this quadratic function, we can refer to the part A. Because to find the inverse function, you must complete the square. So I will just copy this. Alright, 2x minus 3 squared plus 4. That means this is going to be 2x minus 3 squared plus 4 is my y. To get the h inverse, I get the x as a subject. So move the plus 4 to the other side. So y minus 4 is 2x minus 3 squared. So then 2x minus 3 equals to plus minus square root y minus 4. Then now to get my x, I will move the 3 to right side first. It will be 3 plus minus square root y minus 4. Now to get my x, I have to divide by 2. Okay, so I'll just write half, then 3 square root y minus 4. Now what to write? Plus or minus for the square root of 4 y minus 4, it depends on your domain here. Okay, because we know that domain h equals to range h inverse. That means now your range h inverse is less than 0. Okay, so which means range h inverse is less than 0. So this whole expression will be the range of the h inverse. In order to get less than 0, I have to choose minus. Okay, therefore your h inverse is half times 3 minus square root of x minus 4. So that is our h inverse function. Okay, next question number 10. A curve has stationary points 2, -10, and is such that second derivative is 6x. Find the dy dx. So for your information, when you are given y, to get dy dx, you differentiate once. Okay, then from dy dx to get d squared y over dx squared, you differentiate the second time. So now from here, you are given d squared y over dx squared, and you need to find dy dx, means opposite direction, which is integration. Alright, so which means now you need to integrate. So d squared y over dx squared is 6x. So your dy over dx is integration of 6x dx. So when you integrate, it will be 6x squared over 2 plus c. Therefore, this is 3x squared plus c. Now, when you look at the question, stationary points at 2, -10. So stationary points means when dy dx is 0. Okay, the point is 2, -10. which means the x is 2. So now I replace the dy dx by 0 and the x by 2. So 0 is 4, this is 12. Okay, 3 times 4 is 12 plus c. Hence your c is negative 12. Therefore, substitute into this equation. So dy dx equals to 3x squared minus 12 because your c is negative 12. Okay, so done for this part A. Now B, find the equation of the curve. So by looking at this diagram, equation of the curve means you want to find what is your y. Again, now we need to integrate. Okay, so integrate the dy dx that we have just found. Then you will be getting the y. So now my y, okay, I'll copy the dy dx first. My dy dx is 3x squared minus 12. So now y is integrate 3x squared minus 12 dx. So when you integrate, the first term is 3x cubed over 3. Second term is 12x, then plus c. So when I simplify, I will be getting x cubed minus 12x plus c. This is my y. So now, if you don't want to use c, because just now we already use c, you can use other variables. Maybe I use k. So then to find a k, okay, I have to refer to this point, 2, negative 10, because these are the x and y values. So 2, negative 10, that means your x is 2 and your y is negative 10. So I will be getting negative 10 is 2 cubed minus 12 times 2 plus k. So that means you'll be getting 8 minus 24 plus k equals to negative 10. Okay, then you will be getting k is 6. Right? Hence, your y is going to be x cubed minus 12x plus 6. So that's the equation of the curve. Okay, now C, find the coordinates of the other stationary point and determine its nature. So it means that now the other stationary points means that you will be getting another x when the dy dx is 0. Okay, so now let's look at the dy dx. dy dx is 3x squared minus 12. Right, so from here, I will get 3x squared minus 12 equals to 0. That means 3x squared equals to 12. Hence, x squared is 4. Therefore, your x will be plus minus 2. Okay, so go back to the previous question. You are given one stationary point at x equals to 2. That means the other x should be minus 2 right now. Okay, so I will just write the other stationary point. That means the x is negative 2. Okay, so I need to find the point, the coordinates. So again, substitute back into the y. So it will be x cubed minus 12x plus 6. So I will write y equals to x cubed minus 12x plus 6. So when x equals to negative 2, the y is negative 2 cubed minus 12 times negative 2 plus 6. So this is going to be positive 22. So therefore, I get the other point. So the other stationary point equals to negative 2, 22. Okay, so now to get the nature means the second derivative. So I have to copy 6x. Okay, so d squared y over dx squared equals to 6x. So at negative 2, 22, d squared y over dx squared, it will be 6 times negative 2, which is negative 12. Right, which is less than 0. So when less than 0 means that negative 2, 22 is a maximum point. So that's the solution of this part C. Okay, now D, find the equation of tangents to the curve at the point where the curve crosses the y-axis. So when the curve crosses the y-axis means x equals to 0. Okay, so when x equals to 0, your y is, look at the y here, x cubed minus 12x plus 6. So x cubed minus 12x plus 6, it becomes just 6. Therefore, I get a point with coordinates 0, 6. And then now equation of tangents, we need the gradient of tangent, which is a dy dx. Okay, so dy dx, refer back to the previous part. Okay, look at here. Basically, dy dx is 3x squared minus 12. So 3x squared minus 12. So at x equals to 0, dy dx equals to negative 12. Okay, this is the gradient of tangent. So m tangent equals to negative 12. So now we have a point, we have a gradient, then you can find equation of tangent. So use a formula. Okay, y minus y1 is m bracket x minus x1. This is the equation of a straight line. Then from here, I will get y minus 6 equals to the m is negative 12, x minus 0. Then y equals to, here do expansion, negative 12x. Then the minus 6 move to the other side, plus 6. So this will be the equation of the tangent when the curve crosses the y-axis. Okay, now for question 11. The diagram shows the circle, this is a circle, together with the equation, parallel tangents, each with gradients 1. That means this gradient is 1. Okay, this gradient is also 1. Touch the circle at the points A and B. Now find the equation of the line AB, giving the answer in the form y equals to mx plus c. Just 3 marks. Now, when you look at here, parallel tangents. Tangents means that it is 90 degrees. Okay, so here will be 90 degrees. So when you join, here 90 degrees. So now from here, I know that the gradient of the tangent is 1. Therefore, I will say this is the normal. Okay, so I will say MAB. So MAB equals to minus 1. Okay, then now to find the AB, we need to find the points, right? So now A and B are unknown and only 3 marks here. So I am not going to find the points A and B. So what I need to do is, since A and B are on the circle and these two are tangent lines, so this A and B is basically the diameter. Okay, so which means I will just need to find the center. Okay, so I can get the center of the circle by referring to the equation of the circle. So I will write from x minus 4 squared plus y plus 1 squared plus 40. We know that the center is 4 minus 1. Okay, how to get the minus 1? It will be x minus a squared plus y minus b squared equals to r squared. So this plus 1 you change to minus of minus 1. Therefore, I get minus 1 over here. And then the radius is square root 40 because this is r squared. Now, since I know that the AB is a diameter, this is a center, okay, with coordinates 4 minus 1. So now I can form the line AB because we have found the gradients here and also the point C. So now equation of the line AB, which means y minus minus 1, I'm going to use a center, equals to the gradient is minus 1, x minus 4. Therefore, you will get y plus 1 equals to minus x plus 4. At last, your y is minus x plus 3. So this is the equation of the line AB. Now B, find the coordinates of A giving each coordinate in third form. So now, since we have found the line AB, okay, so the A is the intersection between the circle and the line. So I will just need to solve the simultaneous equation. So then from here, write x minus 4 squared plus y plus 1 squared equals to 40. And then the line AB, y equals to minus x plus 3. This is the second equation. So solve the simultaneous equation. So first, or substitute first into second. Or substitute second into first. Okay, because the second one is just a y. So I will write x minus 4 squared plus minus x plus 3. This is our y. Then plus 1 squared equals to 40. So I simplify the second bracket first. It will be minus x plus 4 squared equals to 40. Okay, so now do expansion. So according to quadratic formula or quadratic expansion, if you have plus minus, you will be getting a squared plus minus 2ab plus b squared. Therefore, I will be getting x squared minus 8x plus 16, then plus another quadratic expansion is x squared minus 8x. Another quadratic expansion is, okay, it's the same, minus 8x plus 16 as well. Okay, then move this 40 to the other side because negative 40 equals to 0. Both expansion will be the same. So now when you simplify, you will be getting 2x squared minus 16x. 16 plus 16 is 32. 32 minus 40 is negative 8. Then now I will divide the whole equation by 2. You will get x squared minus 8x minus 4 equals to 0. Now, the question already mentioned in third form means that now you must use quadratic formula to solve this question. So given ax squared plus bx plus c equals to 0, your x will be minus b plus minus square root of b squared minus 4ac over 2a. So now my a is 1 because 1x squared, my b is minus 8 and my c is minus 4. So then my x will be minus 8 plus minus square root of b squared. So minus 8 squared minus 4, 1 times minus 4 over 2a. A is 1. Then from here you will get 8 plus minus square root 80 over 2. Okay, now square root 80 you can change to 4 square root 5. Then when you simplify, this is going to be 4 plus minus 2 square root 5. Okay, here we get two values. One is smaller, one is bigger. So at the graph, okay, from the graph, we know that A is smaller than B, the x coordinate. Therefore, I have to choose a minus. So at A, the x should be a smaller value. Okay, but then the question is asking for coordinates of A. So now I need to find a y. So my y, I will just refer to the second equation. It will be easier. So then I will just continue on the right side here. So my y is negative x plus 3. So at A, my y is going to be negative of 4 minus 2 square root 5, then plus 3. Then you will get minus 4 plus 2 square root 5 plus 3. At last, you will be getting negative 1 plus 2 square root 5. That means my A will have the coordinates of 4 minus 2 square root 5 and then minus 1 plus 2 square root 5. Okay, that's the solution of this question. Now C, find the equation of the tangents at A, giving your answer in y equals to mx plus c, where c is in third form. So since we have found the A, okay, so A with coordinates 4 minus 2 root 5, and then minus 1 plus 2 root 5, and then now I need to find equation of tangents at A. That means the gradient of tangent is 1, okay, so m is 1. So again, use formula y minus y1 is m bracket x minus x1. So I will get y minus minus 1 plus 2 square root 5 equals to, my m is 1. Then x minus the x1, which is the x coordinate of the A. Then now I open the brackets. Or now, if you no need to open the brackets because I'm moving this to the right side. Since here is minus, when you move, you just remain the square, the bracket. So I will get y equals to x minus, this one you times in, minus 4 plus 2 root 5. Then this whole bracket, when you move, you just copy the bracket. Okay, so now here simplify. So from here I will get minus 4 plus minus 1. It will be minus 5. Okay, then 2 square root 5 plus 2 square root 5. It will be 4 square root 5. So to get this form mx plus c, I will just write my y is basically x plus bracket 4 square root 5 minus 5. Okay, so that's the equation of the tangent at A. Okay, so we have come to the end of the video. Thanks for watching. Please like and subscribe to the channel if you enjoy watching this video, and stay tuned for more upcoming videos. Thank you. Bye.